Okay, guys, we're going to look at right triangle trigonometry. And so we're going to find the values of trigonometric functions for acute angles of right triangles, and we're going to solve some right triangles. So this first section here just tells us what the trig functions are. There are 6 basic trig functions. The top 3, I guess, are sine, cosine, and tangent. And then we have what's called reciprocal functions, cosecant, secant, and cotangent. But those are our 6 trig functions. Within that, we base these on a given angle in a right triangle. And then in relation to that angle, we have obviously 3 sides of a right triangle. The side next to it, but not the hypotenuse, is called the adjacent side. The side opposite that angle is the opposite side. And the side opposite the right angle is the hypotenuse. I know you guys are familiar with this. So based on that, for the sine function, we have opposite, the sine of the given angle is opposite over hypotenuse. So it's a ratio of the sides. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cosecant, secant, and cotangent, again, are reciprocal functions. Can't even spell it. Let's try that again. There, that looks like reciprocal. These are the reciprocal functions. And a reciprocal, we just flip the fraction. Well, that's exactly the same thing that happens with our reciprocal functions. Cosecant is the reciprocal of sine. So instead of opposite over hypotenuse, we have hypotenuse over opposite side. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, we have hypotenuse over adjacent. And for cotangent is the reciprocal of tangent. So instead of opposite over adjacent, we take adjacent over opposite. So getting back to those reciprocal functions, since cosecant is the reciprocal of sine, we can rewrite that and say it's equivalent to 1 over sine. Secant is the reciprocal of cosine, so that would be 1 over cosine theta. And cotangent is the reciprocal of tangent, so that's equivalent to 1 over tangent theta. These are called identities, and that's because they're identical. The way I remember them, at least, is that they're identical to each other. Cosecant is identical to 1 over sine theta, so that's an identity. Tangent and cotangent can also be written as a combination of other functions. So tan theta would actually be sine theta over cosine theta, and cotangent would be cosine theta over sine theta. Those are also identities. Okay, on the next page we have an opportunity to practice that. We want to find the exact values of the 6 trig functions for theta. So exact values means we don't want any decimals. We're looking for fractions here. So I have angle theta, and then I just want to identify what's my opposite, my adjacent, and my hypotenuse. So my hypotenuse is always the side opposite the right angle, which would be 17. The side opposite is 8. And the side adjacent to theta is 15. So sine is opposite over hypotenuse. The opposite side was 8, and the hypotenuse was 17. So sine of theta is 8/17. Cosine theta is adjacent over hypotenuse. The adjacent side to theta was 15. The hypotenuse is 17, so we get 15/17. And tangent theta is opposite over adjacent. The opposite side to theta is 8. The adjacent side is 15, so we have 8/15. If we get some fractions and they can be reduced, we should go ahead and reduce those. For the reciprocal functions, we don't even really have to think about those. We just know that they're reciprocals. So instead of taking opposite over hypotenuse, I do hypotenuse over opposite, or take my sine function and just write the reciprocal, which is 17 over 8. Secant is the reciprocal of cosine, so that's going to be 17/15. And cotangent is opposite or reciprocal of tangent, so that's 15/8. In example 2, it says if cosine theta is equal to 2/5, find the exact value of the 5 remaining trig functions for the acute angle theta. In the previous problem, we knew all 3 sides of the triangle and were able to put together our 6 functions. In this case, we're going to use what we know to find all 3 sides and then complete our 6 trig functions. So cosine theta is equal to adjacent over hypotenuse, and we have 2 over 5. So that tells me I'm going to let the adjacent side be 2 to theta and the hypotenuse be 5. So again, this is the adjacent side. This is the hypotenuse. And then we have our opposite side. The opposite side right now, I don't know what that is. I'll put a little X and we're going to do Pythagorean theorem to figure it out. Little Pythag, a squared plus b squared equals c squared. Remember, that's only used for right triangles. We have x squared plus 2 squared equals 5 squared. X squared plus 4 equals 25. We subtract 4, x squared would be 21, and then when you take the square root of both sides, you get x is equal to the square root of 21. And since I want exact values, I'm going to leave it as the square root of 21. Now I have an adjacent side, an opposite side, and a hypotenuse, and I can find my remaining functions. We know that cosine theta, we have sine theta, we have tan theta, and then we have our reciprocals. So the reciprocal of cosine is secant, then cosecant for sine, and cotan for tangent. All right, so for cosine, we already have that one. That is 2/5, and so the reciprocal function, secant, would have to be 5/2. Sine, then, is opposite over hypotenuse, so square root of 21 over 5. And then the reciprocal function would be 5 over the square root of 21. Now, normally we'd like to simplify that, but in this case, I'll let you leave the radical in the denominator. Tangent is opposite over adjacent, so that one's going to be square root of 21 over 2, and then cotangent would be 2 over the square root of 21. Actually, we're going to come back to this one when I see you again, we'll do that. So we're going to save that for later, which would be Tuesday. And we're going to jump down here to number 3, which you don't really need it for the other problems. So example 5, it says to find the value of x and round to the nearest tenth if necessary. So my theta, my angle is actually given this time, so I want to identify my parts that I have been given. So in this triangle, I have the adjacent side and I have the hypotenuse. And I just want to identify what trig function uses hypotenuse and adjacent. And so cosine of theta is adjacent over hypotenuse. So I'm going to substitute what I have in. Theta was 42 degrees. The adjacent side is x, and the hypotenuse is 18. Now you need to keep in mind that cosine of 42 degrees is a number. There is a value that goes with that. So basically this tells me some number equals x over 18, and then to solve for x, I would just do some basic algebra and multiply by 18 here. So x is equal to 18 times the cosine of 42 degrees. And I would put this in my calculator. Now we do want to make sure that we have our calculator in degree mode and not in radian mode. So you want to go to mode on your calculator and make sure it says degree. It should indicate at the top of whether you're in degree or radians in the usual screen. But if it doesn't, then you want to go ahead and change that in your mode and make sure it's on degrees. And then if you do it correctly, you should end up with approximately 13.4. So that's x, or the adjacent side. Okay, then I'm going to go over here to 3a. And this time we have a 53-degree angle. We are given the hypotenuse, or at least a variable for that, and the opposite side. So we're going to do sine, uses opposite and hypotenuse. And substitute. So sine of 53 degrees equals 15 over x. So this one is a little bit trickier. It just takes a couple more steps. So basically, what I'm going to do is I'm going to multiply by x to get it out of the denominator, because you can't solve for x if it's in the denominator, which would give me x times the sine of 53 equals 15, and then you have to come back and divide by sine of 53. So you get x equals 15 over the sine of 53 degrees. So just know that anytime you have the variable in the denominator, that you're going to end up dividing by the sine. Okay, you don't want to multiply it, you're dividing by the sine in the end. So basically, my x and my sine kind of switched places, if you take a look here. And then we're going to simplify that using our calculator, and we get about 18.8. Okay, the next part of this, and up to this point we've solved for x. Now we're going to solve for the actual angle here. And so this is talking about our inverse trig functions. In order to solve for theta, what we want to do is take the inverse of the sine function. And so I'm just going to break it down here on the right just a little bit. But we've got sine theta equals x. And so I want to know what that theta is going to be, or how I would solve for that. To do that, I'm going to do the inverse sine basically on both sides. And if you look at your calculator just above the sine button, there, it's not another button, but just above the sine button, you'll see the sine inverse. We only use that if we're solving for an angle measure. So the result is, basically the sines kind of cancel each other out, and we're left with theta equals the inverse sine of x, or whatever that value is. So the inverse sine would be theta equals sine inverse of x. For inverse cosine, theta equals cosine inverse of x. And for tangent, theta equals the tan inverse of x. So again, you only use the inverse function when you're solving for an angle measure. In example 5, it says find a missing angle measure. So that's what we're going to do. We're given a couple of sides, and we want to find out what theta is. It says use a trig function to find the measure of theta, round to the nearest degree if necessary. So we're going to start with a trig function. We have angle theta, we have the adjacent side, which is 11, and we have the opposite side, which is 26. So a tan function uses opposite and adjacent. Tan theta equals opposite over adjacent. And then we're going to substitute. It's okay. Just disregard Mr. Moulton. So that's what I'm going to do. I'm going to do the inverse tan of the opposite over adjacent. Which is 26 over 11. And we'll get an approximation for that. It says round to the nearest degree. And it is about 67 degrees. Okay, so actually the picture below here goes with the following, the next questions, and that's talking about angle of depression and angle of elevation. And so we have to think of this as two parallel lines. So if you can remember back from geometry, we have two lines. I'm going to make them parallel. I'm going to put a little parallel marker here. Cut by a transversal. Okay. What we have is alternate interior angles. We first have an angle of depression. Angle of depression happens when you are looking forward and then you look down. So think of looking down as depression. And then the guy on the ground there, he is looking up at the airplane, so that's an angle of elevation. Looking down is depression, looking up is elevation. And the angle of depression, again, I cannot spell. The angle of depression is equal to the angle of elevation because they are alternate interior angles. Alternate interior angle theorem says that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So If we find the angle of elevation, we've got the angle of depression and vice versa. And we have an example of that here with our little airplane problem. It says a ground crew worker who is 6 feet tall is directing a plane on a runway. If the worker sights the plane at an angle of elevation of 32 degrees, what is the horizontal distance from the worker to the plane? So we already have it marked off here. We just want to find out what x is. And we know that the height from the line of sight of the person to the plane is 150 feet. And we've got an angle of elevation, which is 32 degrees. We can disregard the fact that no, I guess we have our little guy here that's 6 foot tall. So we can see him way over here. He's so tiny, but he's right here and he's 6 foot tall. And we are actually, his line of sight goes across here. So in order to do this correctly, we need to subtract this 6 feet. Okay? And so if we're looking at our triangle, and this is going to be our right angle, we want to find x right here. We're going to have to take 150 minus 6, which is 144 feet, and use that to solve for x. So we actually have an adjacent side, and we have an opposite side. And I want to use tangent to help me solve for this. So we've got tan theta is opposite over adjacent. And so the tangent of 32 degrees is equal to the opposite side, which is 144, and the adjacent side, which is x. And so like I said before, when x is at the bottom, basically the x and the function, the trig function, switch places. So that would be equivalent to x equals 144 over the tangent of 32 degrees, and then we would solve for x. All right, we will see you on Tuesday. Happy homework.